let's look at critical points. And these are what are going to help us find our smallest and our largest values. So critical points are defined from this idea that people realized if f has a local extremum at c, then we know that f prime of c will equal 0 or undefined. In other words, if you're going to have a point be the biggest point of all the points around it, it's got to look something like this or something like this. If it's going to be the smallest, it's got to look something like this or like this. And in both cases, you can see that at the maximum, the derivative is either 0 or it's undefined at these two kind of sharp points there. So that meant people kind of thought and said, okay, well, let's call all of these points critical points. So critical points are locations where f prime of x equals 0 or undefined. So that's a critical point. Now, note not all critical points are extrema. I'll show you some more examples here in a second, but the simplest one is just imagining something that levels off but then keeps going up. Obviously in the middle here, this isn't a minimum or a maximum, so therefore we've got kind of the counterexample where not all critical points are extrema, but every extrema will be a critical point. So we can see all the examples here. You can have basically the maxima are those first two, A and B. And then you've got minima for C. You could also have one like we saw before, a minima like this. And then you've got examples where f prime of C is 0 and f prime of C is undefined, but there is no extrema because it continues increasing as you go through it. So if we want to use critical points to find our minima and maxima, we're going to identify, critical points will identify all the possible locations for minima and maxima, but they may not identify absolute. Extrema. Because, for example, something like this. So if you have a function like this point at the end would be our absolute minimum, but it's not a critical point. But the critical point does happen in this case to identify the absolute maximum. So this is the absolute maximum and a local max. And this right here is the absolute minimum. So if we want to look for the global or the absolute extrema, we have to look at both critical points and a couple other things, which we'll see here in a second. So our first example, find the absolute maxima and the minima for the range of 1 to 3 on the function of negative x squared plus 3x minus 2. So the first step is to consider the endpoints. So f of 1 is equal to 0. F of 3 is equal to negative 2, and you can plug those in and check. But those are your endpoints. Then we're going to check our critical points. So f prime of x will be negative 2x plus 3. So f prime of x equals 0 when x equals 3/2. So then f of 3/2, plug it back into the original function. and that will give us 1/4. So now we're going to compare all of those, 1/4, 0, and -2. So this is our global max, and this is our global min. So always when you're checking for global or absolute maxima and minima, check the endpoints and check the critical points, and then just see which is biggest, which is smallest, and that tells us our absolute maximum, our absolute minimum. Another example here is on the range 0 to 2. Again, it's closed. For the function of f of x equals x squared minus 3x to the 2/3. So we'll check the endpoints first, just because that doesn't involve taking a derivative. F of 0 equals 0. F of 2 equals 4 minus 3 times the, well, we'll just say 2 to the 2/3. And if you plug that into a calculator, you get about -0.762. So then let's check the critical points. F prime of x is going to equal to 2x minus 2x to the -1/3. And so this means that our derivative, this will equal 0 when x equals what values? X is definitely going to equal 0, and is that the only position? I believe that's the only location on this range, so that means we don't actually need to consider it, but you can always graph this and look for the intercepts. If I factor out an x, does that help? Actually, that can help a little bit. So let's try factoring that real quick. X to x, we get 1 minus x to the -4/3. And so actually when x equals 1, that's another value. Because 1 plugged in here, we're going to get 1 minus 1. So we've already evaluated f of 0, so now I have to evaluate f of 1. And that will be 1 minus 3 times 1 to the 2/3. So that will equal -2. So we got -0.7620 and -2. So this is our global minimum, and this is our global maximum. Now we do have to be careful, because if I had gotten, say, -1 here, I would have to exclude it because it's not between 0 and 2. So just double check when you're solving problems that you do look for that.